Imagine a world where gravity is just a suggestion and 40,000 tons of titanium can float on a lake with zero visible columns. You aren't looking at CGI, computer-generated imagery. You're looking at a structural glitch. China has officially breached the forbidden frontier of design, building 14 masterpieces so complex that traditional math predicted they would instantly collapse. From buildings that literally breathe at -40 degrees to massive domes that force you to enter through a secret underwater tunnel. These are anomalies in the fabric of reality. The future of engineering isn't. It's a physical reality you can touch. Brace yourself because we're about to cross the line where logic ends and the impossible begins. Subscribe. Your support helps us produce more high-quality content. Number 1. National Center for the Performing Arts, the Egg. This titanium and glass ellipsoid, designed by Paul Andreu, is a structural anomaly that sits submerged in a 35,000 square meter artificial lake. To solve the hydrostatic paradox, engineers faced a nightmare. The building contains 165,000 cubic meters of air, creating a massive buoyancy force that wants to eject the building from the ground like a cork in water. To counter this, they engineered a massive, weighted concrete bowl foundation that acts as a ballast. The exterior is a marvel of precision, featuring 18,000 interlocking titanium panels and over 1,000 sheets of ultra-transparent glass. None of these panels are identical. They interlock like the scales of a biological organism. Visitors must descend into a 60-meter transparent tunnel beneath the lake bed to enter, walking directly under millions of gallons of water. This entire passage is shielded by multi-layered waterproof membranes and a redundant system of high-pressure pumps that monitor moisture levels in real time to ensure the egg never succumbs to the crushing pressure of the lake. Hit the subscribe button and motivate us to bring you even better quality content. Number 2. Guangzhou Opera House, the Twin Boulders. Modeled after two pebbles eroded by the Pearl River, this Zaha Hadid masterpiece features a revolutionary non-repeating steel diagrid where none of the 75,000 joints are identical. In traditional architecture, symmetry is the safety net. But here, the twin structures lean at radical, asymmetrical angles that create unbalanced load paths. Every single steel connection had to be custom cast using 3D modeled molds because standard beams simply couldn't meet the shifting geometric requirements. The building uses a double skin system. The outer granite skin handles the brutal structural stresses and wind loads, while the inner shell is a completely separate acoustic chamber. This interior is carved into fluid, cornerless geometry, using glass fiber reinforced gypsum to ensure sound waves travel with zero interference or echo. It's not just a building, it's a 70,000-ton musical instrument tuned to perfection. If you appreciate our efforts, reward us with a subscription. Number 3. Harbin Opera House, the Frozen Wind. Engineered to survive the brutal -40 degrees Celsius Arctic winters of northern China, this building is a masterclass in thermal expansion management. Most materials become brittle and crack in such cold, but this facade features breathing expansion joints that allow the white aluminum skin to shrink and grow by several centimeters without losing its airtight seal. The construction was a race against nature. Because it was built on unstable wetland soil, engineers had to drive hundreds of specialized friction piles deep through the silt and into the permafrost to provide a stable anchor that wouldn't shift during the spring thaw. Inside, the 1,600-seat hall is a warm contrast to the icy exterior, wrapped in hand-sculpted Manchurian ash wood. Each wooden louver was steamed and bent into complex, non-parallel curves using digital fabrication to guide sound waves with mathematical precision, creating an acoustic environment that feels organic yet is strictly calculated. Number 4. Shanghai Grand Theater, the Glass Arc. The defining feature of this building is its massive 6,000-ton treasure bowl roof that cantilevers 60 meters out from its base. In the world of physics, a cantilever this size creates a massive tipping force that should theoretically topple the structure or snap the supports. To solve this, engineers hid a colossal system of steel trusses within the cup of the roof, transferring the weight back to a central concrete core, the building's spine. But the challenge didn't stop there. Shanghai is built on soft river silt, which is notoriously poor for supporting heavy loads. Engineers utilize deep friction pilings that use the surface tension of the soil to hold the building's weight. These piles were driven to varying depths to prevent differential settlement, ensuring the enormous glass walls, which have almost zero tolerance for shifting, don't crack under the uneven weight of that massive hanging roof. Number 5. Jiangsu Grand Theater, the Gravity Defier. Comprising 4 massive lotus seed volumes, this structure utilizes asymmetric load paths that baffle the naked eye. While most buildings send weight straight down, the weight of these concrete shells twists through hidden diagonal steel trusses, following a spiraling path to the ground. Every angle of the facade was calculated using parametric software to keep thousands of tons of material suspended in mid-air over a central plaza. To stabilize these leaning forms, the foundation acts as a deadman anchor. This involves a massive subterranean concrete block that utilizes the Earth's own mass to pull down on the opposite side of the cantilever. It is a constant tug-of-war between the leaning building and the planet itself, creating a structural balance that allows the seeds to look as though they are floating away from each other. Number 6. Shanghai Oriental Art Center, the 5 Petals. Viewed from above, this orchid-shaped structure consists of 5 separate pavilions, or petals, that are connected at a central atrium but remain acoustically decoupled. This is one of the most difficult feats in theater engineering. Each petal, housing a concert hall, opera hall, and theater, is structurally isolated with rubber dampeners and air gaps to prevent low-frequency vibrations from a drum kit in one venue from traveling through the floor and ruining a quiet piano solo in another. Each petal rises from its own independent reinforced core. The entire complex is wrapped in a high-tech laminated glass skin featuring an integrated perforated metal layer. This layer acts as a solar filter, reflecting heat during the day to reduce cooling costs, while allowing the building to glow like a translucent lantern at night. Number 7. Suzhou Bay Grand Theater, the Infinity Ribbon. This structure is famous for its 500-meter-long metallic ribbon that flows over the roof and under the plaza. Many think it's purely decorative, but it actually acts as a structural tie beam. This ribbon stabilizes the 2 main theater volumes against high wind loads coming off the neighboring lake, acting like a giant steel staple that holds the complex together. The construction was an engineering nightmare. Building on a lake bed required the use of a cofferdam system, essentially building a massive temporary wall in the water and pumping the inside dry. Engineers then poured the concrete shell in underwater stages using specialized anti-washout concrete additives. This ensured the foundation was rock solid before the flowing steel ribbon was hoisted into place using some of the largest cranes in Asia. Number 8. Zhuhai Grand Theater, the Scallops. Rising 90 meters from a reclaimed island, these 2 giant scallops face a unique enemy, Category 5 typhoons. To survive, the shells utilize a hollow-core shell design, a sandwich of steel and concrete that provides maximum rigidity with minimum weight. This reduces the sail effect that would otherwise cause the building to catch the wind and collapse. To combat the 200 km/h winds and the corrosive salt air of the South China Sea, the concrete was reinforced with anti-corrosive microsilica and anchored deep into the granite seabed. The glass facade isn't rigid. It's engineered with flexible, high-tensile gaskets that allow the glass panels to flex and bow several centimeters under extreme wind pressure without shattering, effectively allowing the building to ride out the storm. Number 9. Changsha Meixihu Grand Theater, the Flowing Petals. This Zaha Hadid design completely rejects the concept of a right angle. It uses a non-uniform load distribution system where the weight of the building travels through a chaotic steel framework that mimics biological cellular patterns, Voronoi diagrams. Because the fluid, sinuous shape is so complex, standard construction methods were impossible. The construction required sacrificial formwork, thousands of custom-made wooden and CNC milled molds that could only be used for a single concrete pour before being broken apart. This labor-intensive process was the only way to achieve the white, silk-like curves that transition seamlessly from the floor to the ceiling, creating a cavernous interior that feels like it was grown rather than built. Number 10. Wuxi Grand Theater, the Wings. Featuring 8 massive roof wings that extend far over the waterfront, this building is a masterclass in counterbalanced cantilevers. The wings are so long that the weight of the tips would normally cause the steel to snap at the base. To prevent this, engineers hid massive concrete counterweights thousands of tons deep within the rear foundation of the building. These weights act like a seesaw, pulling down on the back to keep the wings up. The wings themselves are made of lightweight steel skeletons wrapped in shimmering aluminum panels. Integrated into these panels are 50,000 individually programmable LED lights, allowing the structural wings to function as a massive, low-resolution digital screen that reflects off the lake's surface at night. Number 11. Chongqing Grand Theater, the Crystal Ship. Chongqing is known as the Mountain City, and building this theater required conquering a steep riverside cliff. The soil stability here changes drastically as the Yangtze River rises and falls by up to 30 meters throughout the year. To ensure the Crystal Ship didn't slide into the river, engineers used slope stability engineering, anchoring the building into solid bedrock with massive steel tendons. The structure features extreme cantilevers that mimic a ship's bow. These are held in place by massive steel trusses that transfer the load back to a central core anchored in the mountain. This ensures that even when the river floods and the soil becomes saturated, the massive glass-clad theater remains perfectly stationary. Number 12. Nanjing Polygrand Theater, the Contrast. This building features a sharp, aggressive intersection where curved glass slices cut through angular, heavy concrete blocks. This creates a massive problem known as differential material stress. Because glass and concrete expand and contract at different rates when heated by the sun, a rigid connection would cause the glass to explode. Engineers had to invent specialized, flexible sliding gaskets and joints at every single intersection point. These joints allow the materials to move independently by several millimeters. Additionally, high-tech fiber optic sensors were embedded in the foundation to monitor the ground in real time, alerting engineers to any microscopic shifts in the asymmetric weight of the design. Number 13. Hangzhou Grand Theater, the Crescent Moon. To create this titanium-clad crescent, engineers abandoned traditional curves in favor of folded plane geometry. The exterior is actually a series of thousands of flat titanium planes, each folded at precise mathematical vertices to create the illusion of a smooth, continuous curve. This approach was mirrored in the interior's acoustics. Instead of using standard acoustic foam or fabric, the sharp angles of the interior walls were used as angled reflectors. Every surface was positioned via computer algorithms to bounce sound waves toward the audience with laser-like precision. This allows the theater to achieve perfect, natural acoustics using nothing but the hard, geometric surfaces of the building itself. Number 14. Polygrand Theater Shanghai, the Geometric Void. Designed by Tadao Ando, this building is a rectangular concrete box with a perfect cylinder carved out of it at a diagonal. This creates a massive torsional, twisting weakness. Because the building is essentially missing its center, it wants to twist and collapse under its own weight or during high winds. To prevent this, the internal steel columns don't go straight up. They follow spiral paths, each angled differently at every floor to maintain the integrity of the circular void. The foundation uses rotational pilings to lock the building into the earth, ensuring the diagonal wooden tunnel remains stable, even as wind pressure tries to rotate the entire structure around its axis.